In this lecture, I would like to demonstrate the use of the Math library. I will use this example using the random number generator as an example to show you how to use the Math API application programming interface. Random number generator is very useful to simulate some diagram like this. It can also be used to simulate a 5-dimension weather model, as you can see right here. It includes the geometrical 2D landscape and also third dimension for the height. And also in each box, there are temperature and wind speed, several other parameters. So it can be 5D or higher dimension. But it can be simulated so that we know when or where the hurricane may be landing somewhere in the United States. And the same method can be used for chemical war. Now we can use the Monte Carlo simulation method based on the random number generator to simulate how the molecule may react after certain chemical activity. We can use the random method from Math library to generate a random number ranging from 0 to 1 but not including 1. This method will return a floating-point number between 0 and 1 but not including 1. Using this function, we can generate a number that ranges from 0 to 6 but not including 6 by multiplying the result from this function by 6. And this 6, we can name it a span that show you how wide the range of the random number will be placed. And then we can use integer as quantizer that will trump off all of the fractional part. So the samples will be these numbers 0, 1, 2, 3, 4, 5. So the number of the random sample count are 6. So this 6 actually is the number of the random sample count. And the difference between this one and this one is that this one is continuous domain. It ranges from 0 to 6 but not including 6. This one is discrete domain that actually only has the discrete sample from 0, 1, 2, 3, 4, 5, totally 6 elements. And then if we plus 1, the random samples will be 1, 2, 3, 4, 5, 6. So this one, we call it base. And this base actually will be the number 1 here, and that same number will be the value for each face on a die. Then we can again multiply this quantized part by 2. Then the sample value will be 0, 1, 2, 3, 4, 5 times 2. That will become 0, 2, 4, 6, 8, and 10. And then we plus 1. The sample space will be 1, 3, 5, 7, 9, 11. So this formula will tell you the step size is 2. That is the distance between 2 samples in the set. And then the base is 1. And number of elements is 6. In the previous lecture, we talked about one mathematical function, math.power, and another mathematical constant, math.pi, to calculate the area for a circle. And we copy the program over and rip out those not related to arithmetics. We create this random number class. Now, we are going to introduce another mathematical function. In the previous class, we tried to read in the data from the console by user's input. Now, if we want to generate a number by the computer, what can we do? We need to call a mathematical random number generator. To do that, for example, if I want to create a number between 0 and 1 but not including 1, I can declare A as double and then equals Math.random. Call this method. A method is a function. And then for B, I do the same thing. it will create a number from 0 to 1. And then a plus b equals c. If we want to create a random number for integer, let's try this. If we want to create a number between 0 and 9, we make times 10. This will create trouble later, but let me show you the error first. And then g equals e minus f. Let's compile it. It shows that the double type, because the mathematical function random will generate a double type data, and then we try to convert it to an integer. The compiler don't allow it. To avoid that, we need to put parentheses between them, and then put a int there to convert the data type from double to integer. Similarly for f. Then let's compile it. It passed now. Let's run it. So the A is 0.59 something, B is 0.15 something, it equals 0.74 something. And then we generate a number for E, that's 1, and then F equals 3, E minus F is minus 2. So this number generated by Math.random is between 0 and 1. When it times 10, is it between 0 and 10, but not including 10. But it got converted to integer, so we chunk off the decimal places after decimal point. It will be an integer from 0 to 9. Let's run it again. This time is 2. Oh, we make a mistake right here. Let's change it to minus. The math is okay, but the representation is wrong. Let's compile it again. You know, programmers make mistakes sometimes, but we need to make adjustment. So right here, 3 minus 6 is minus 3. Let's run again. The reason I run so many times is because that we want to have a random number. I will show you that these numbers are computer generated. I keep running it to show you that it's randomly generated. It never repeats itself. Well, in the long run, it might repeat, but it will be random enough for you to trust it. So let's summarize about the random number that can be generated from Math.random. Basically, Math.random will generate a double value ranging from 0 to 1 but not including 1. And then we can time by a span. That span actually will be the range that x will fall into, but not including the number span. And then we plus a baseline. We move the range from 0 to baseline. And these are continuous domain. After that, we can use the quantizer with int. And with the quantization like this, we will generate a integer value I that's in range 0 to 1 but not including 1. And in reality, this only has one sample that is 0. So this function actually is useless. And then if we times count, we will generate an integer value in the region of 0 to count, but less than count. And then if we plus a baseline, we will move the range from baseline to baseline plus count. And these are only the integer samples. And then if we times the step, then we will get totally count number of elements, and then each one separated by the step. And then it starts from the baseline. Thank you.